Hello CIS 1400 and welcome to another week. We're in Module 8 and I've been waiting for this module for a while now. This is actually one of my favorite units to kind of discuss and talk about because it's where it kind of all starts to come together, I feel, in object-oriented programming. So if you haven't had a chance to read Chapter 14 yet, please make sure you do. Please at least make sure you read up until you get to at least inheritance and polymorphism. Those are topics we'll cover more in the next module rather than in this one. In this particular module, we'll get through the basics of a class, the basics of an object, how to create a class, write a class, how to instantiate an object of the class, and what all that even really means. So we're going to spend a lot of time coding through these videos. This will be broken up into a couple different videos, maybe 2 or 3 depending on what we get through. I don't want them to become too long and too much. And again, if you get any questions throughout, please post them in the discussion thread below. But let's kind of get into the basics of it. So I'm going to create a new file here just to get things started. And I'm going to call this file a person, because what I'm going to create is a person's object. So I think that'll be kind of interesting. Here's what an object basically is. If you recall in last week's module, Module 7, we started talking about parallel arrays and how we could have corresponding data that relates to a given object or thing, kind of all at the same index value so that we can pull the data appropriately so it all relates to one particular thing. It wasn't necessarily my first or best option there, but it is something we can do. I feel I've always felt a better option is to talk about things in terms of what they are instead of breaking them up in individual attributes and objects or individual pieces. So start talking about them what they are, meaning start talking about them in terms of an object. An object is simply an encapsulation of attributes and methods. So what I mean by that is we're creating a single container to hold on to all the data that something may keep track of and all of the behaviors that something may do. So for instance, like a dog. A dog has a name, it might have a gender, or it has a gender, it might have like an address that it lives at or something like that. But it also has things that it can do like run and jump and bark, and all those things may not be like codable per se, but the dog itself encapsulates those ideas. It has things that it knows about itself or that we know about it, and it has things that it can do. Lots of items can be thought of in terms of objects. Think about rational numbers. Okay, rational numbers are numbers that can be written as a fraction. Well, they have a numerator and a denominator. Those are attributes of the rational number. You can do different things with rational numbers, like you can simplify them, write them in a lower term. So instead of writing 6/8, you can then write 3/4, and it's the same thing. You can add rational numbers together, subtract them, multiply and divide them, do all sorts of other things with rational numbers so that all of this stuff can be wrapped up into one pretty container and to one class, and then we can build others upon it. The other kind of advantage we have in creating classes and objects is we can create this one blueprint, and then we can create several instances of this one blueprint, which is really nice. So let's say I want to encapsulate data about people. Okay, which is what we're going to do in this particular example. People have a first name and a last name, and they might have a phone number and address, and they can do different things, but the trick is, though, just because I'm writing this stuff out doesn't mean that all people have the exact same information and all people have the same things that they can do. We all have the same type of information, but my information might be different than yours. So what we're doing is creating that container that can hold on to those pieces, and then we will instantiate or create instances or objects from this blueprint that all hold on to that information but hold it onto it differently, or different versions of it. So let's kind of get into an example of what I mean. So first of all, if I wanted to create a person might have things like a name, and I might be able to enter a name as Billy Johnson. Okay, and that person might have an address. And that address might be 2315 South, oops, put this in a string, 2315 South 1st Avenue. Okay, And they might also have a phone number. And that phone number might be something like 334 1213 4567. Who knows? Okay, so there's a phone number. Okay, it's just a series of integers. But either way, we've got all this stuff. But let's say I've got another person. Instead of Billy Johnson, I want Samwise Ganji, okay, or whatever it may be. Well, now I've got to make new variables for all these things and that kind of business. And if I've got 50,000 people, what I don't want to have is name 1, name 2, name 3, name up to 50,000. It doesn't make any sense. Plus the addresses and the phones, my program would be exceptionally long and very difficult to parse through. And every time I had to make a new person, I'd have to add more stuff to the code, which doesn't make a ton of sense. So what we have is a better way. We can encapsulate all this information into a thing called a class, and then we can build things based off this class. Classes are just containers to hold attributes and methods. We start with a class identifier, so we say class, and then we give it a title. The title should be noun-like in fashion. Okay, it should always also start with a capital letter. So when I'm grading projects and things like that, those are some of the things I'm going to be looking for. For us, we're going to create a person. Okay, and what we're going to do is create it almost like a function, but I'm going to pass in a certain word here. I'm going to call it an object. Since I don't have a definition to kind of base this person off of yet, Python comes with a predefined version of person, and it's called object. It's the most basic building block of anything in the Python programming language. And every programming language that's all object-oriented has this kind of basic unit. Whether they call it object or not, it depends on the language. Most would likely call it object. But either way, this is just our basic unit, and then we can do certain things from it. Okay, like print the object or determine if it's equal to something else, or realize it as a string or anything like that. Okay, now in this I can start actually building information. Okay, so I can start placing in those things, but there are some special pieces that I need out of this. So I'm going to create something called a doc string here, and a doc string is just a triple quoted string that kind of details what I'm making. So this is going to be a class definition of a person object, right? Those are non-executable, they're just simply comments. And now the next thing that I want to put in here into every class is basically a constructor, okay? What a constructor is, it's a special function that allows me to build an object, okay? Just like anything that you can think of in the world, including people or animals or plants, they all had to be built from something. They had to come in with some basic units to know how to build that particular instance. And we're going to do the same thing with our programming objects. So, but we have to have this special function called init in the Python programming language. So we say def underscore underscore init underscore underscore. You're going to notice that kind of pops up, and I get this word self inside there. Don't worry about the word self, we'll talk about that in a little bit, just know it kind of needs to be there. And what this function does is this allows me to instantiate an object, okay? The word self gives us the ability to reference the particular features of this object, the attributes or the behaviors of it. So it's kind of a self-identifying marker that says, hey, anytime I use this word self, I'm speaking about a specific instance or one specific thing of this class persons here. If I don't have that word self, then I'm talking about the blueprint itself and not any one specific instance of it. So that word self is pretty important. Now you'll never actually pass anything to it. It's an argumentless parameter. You'll never actually give it information, but it does kind of need to be there, because what it does, it allows me to pass in attributes. So what I would do is say something like self.name, okay, and here I can type in Billy Johnson. Okay, and I could do something like self.address equals, and I could say 231 South 1st Avenue. All right, and I can go self.phone, okay, and I can put in a phone number, 312-845-9721. I don't know if that's what I typed in earlier, but now I've got this. Okay? So now that I've got this definition set up, what I'm going to do is I'm actually going to make a brand new file, because what I want to do is be able to test this, okay? And right now this is just a definition of blueprint, a non-executable piece of code, to be perfectly honest with you. And what I'd like to do is make something that is executable and something that I can use. So I'm going to go with person test, just to see how it looks. And let's split screen this so we can see both at the same time. So I'm going to move this to the right, zoom that out a little bit, okay? Zoom this one in. So I'm going to go def main, okay? And in here I want to create an instance of this object, okay? So now through your reading you probably understood that there's a keyword here that we have to use, maybe something like new. We don't actually use the new keyword in Python. What we do is we just kind of call upon the class as if it's a function. And what it'll do is start to build something. But what I do need is a variable to kind of store it in. So let's just call it person1 equals a person, okay? And this isn't going to work the way that it is because this person's test has no relation to persons.py, so I really do need to import it. Now the way I like to import classes when I'm doing that, I like to use, instead of import person, okay, I like to use the from keyword, person import, and then I'll do a star. Because then I could put like one file with several classes in it if I want, or anything like that, and it allows me to grab all of them at once. So this gives it some interaction between this person's test file and the person.py file. You saw us using imports. They always start talking about random information, or some of you have used the math module, and we talked about that before. But before we just did import random or import random, and we always had to do like random dot and then call something from it. The from syntax allows me to kind of bring it in and then expedite the whole person dot piece, and now I can just call upon the function that I wish, okay? So now with this person1, I can actually do stuff with it. Like, let's say I wanted to print its information just to see what's there. So let's go with person, or print person1 dot, and you'll notice as soon as I press the dot, now I've got these fields that I can access. So I can print that person's name if I want. And let's just run this main method so we can see it. Okay. And we'll hit execute or run real quick. And you're going to see that it prints Billy Johnson, right, which is kind of neat. Now I can actually make other persons as well. So let's make a person2 equals a person. Okay. And we'll print person2 their name. And so we'll print, and you're going to see Billy Johnson gets printed twice. Well, that's because our name attribute only has the ability to become Billy Johnson, and that's it. Now, that's probably not the best use of our time, but let's see how we can modify this so we can get unique person objects throughout this, okay? So right now, all of this stuff is kind of hard-coded to be this one in particular individual. Not probably what I want. What I would like to see happen is that this over here, this test program, is able to interact with this constructor function to build unique items in some way. So what we need to do is set this function up so that it can set parameters, maybe something like a name, the address, and the phone number. Okay. So now if I come over here, you're going to notice that when I create a person, let's call it person1, which is a person, we need to start providing it with information. So you'll see self is here. Let's see if we can bring that back. We need address, name, and phone number to get defined. Okay. So what I'd like to do is first define name. Okay. So maybe we'll type in Zach. Okay. I'll just do single names at this point in time. The address will be 23 North Main Street. And the phone number might be something like, let's see if we can decrease the size of this, 555-2314. Okay? And so now if I come over here and actually print person1 dot name, you're going to notice that it's no longer Billy Johnson. Oh, actually, it still is Billy Johnson because we forgot to actually use these parameters throughout here. So even though I have information going in, they're not getting used. So what I really need to do over here, Sorry about that, but I need to actually use this stuff. So the name attribute or the name parameters coming in, I need to set it into the name attribute of the object. So I'm going to put name here. And now these are actually different names. This name right here, this local variable, the parameter to this init function, this is being used here, and self.name is actually different. Self.name is another area in memory with a similar name to it, or identifier, I should say, but it does have to be preceded with this word self, otherwise it won't work particularly right. Let's take the address. We'll do address here. And here we're going to do phone number. And just see that these don't have to match phone and phone number, but notice that phone number is what's getting passed in. That's going to then get assigned into self.phone. Okay, so now if I run it, I should see that I've got Zach. And Zach has an address. If I can spell it, address, and print person 1 dot phone. Okay, and so now I can print out all those things and do whatever I want with it. Okay, but the best part is I've got this one particular thing over here, and I can make several instances now of person. Right, so instead of just person 1, I can call it person 2 equals a person, and this could be Sam, and Sam lives at 34 South Washington. Sam has a phone number of 432-5656. Okay, and so if I go and I print out person1 dot name, and I do a quick print of person2 dot name, you're going to see that they're different, which is really neat. Now I've got this one particular file that can actually hold on to information for several different instances, and I can create as many instances as I want. I can create 50, 100, 10,000, doesn't really make a difference. They all have a name attribute, address attribute, and phone attribute, which is really kind of neat. So this is kind of the idea here of what we can start to build certain pieces of this so that they all can hold on to their own pieces of information. Okay? Whoa, what just happened there? Okay. So, one thing to be mindful of, person 1, person 2, and any other persons that we have, in this particular program over here, persons test, their information is easily seen, as we just witnessed, so we're able to print out their information just by accessing it directly. But the problem is we're also able to modify it. Person1 dot name, and let's change it from Zach to Bill. Okay. Let's do a print statement once before we change it. If I can spell change, come on. All right, before change, we'll do person1 dot name, and then we'll do it once after change. And we'll do, oops, backspace, person1 dot name. Okay. And before the change, person1's name was Zach, which it absolutely was, but after the change, person1's name was Bill, and that's probably a bad thing for us to do, being able to modify the attributes of an object without going through any sorts of checks and balances whatsoever, or through any issues. Now that's where the kind of the second piece of this comes into play, being able to bring methods into this, so some actions that we can do, specifically accessor and mutator methods. But what I'd like to do is at least first solve the problem of making it so that I can't do this, and then we'll talk about how we can get into accessor and mutator methods. So first and foremost, what I want to do is I could very easily make this information kind of a pseudo-private variable per se in Python. There's never like true private variables per se, but what we can do is if I precede this with 2 underscores, okay? Watch what happens over here when I try to change it, okay? It's going to say before change person1.name. Well, I can't use it because person1.name doesn't exist, but if I put those 2 underscores in front and I try to do that here, here, and here, right? Let's just see what happens, okay? Because I did change the name. Might as well look and see if it works. And it's still going to throw a fit at me, okay? Because it's going to say that this name attribute doesn't exist. But that doesn't make any sense. Of course it exists. I have it written over here. But Python has gone through something where it's made this particular attribute what we know as private, okay? So now this is a private attribute. And now it doesn't allow my program over here and from anywhere outside the class to have access to it, at least direct access to it. This is what we call a public attribute with the way that it's written, because I can actually change the address still. It doesn't change anything about address or phone number, but now I can't go through and modify the name in any way, shape, or form. So when we're actually writing out our programs and our classes, what we'd like to do is make sure that the attributes that we write are always private so that we can't modify them without going through some sort of checks and balances. I mean, picture like a debit card, per se. We wouldn't, or even a bank account. We wouldn't want the person's account number or balance or the ability to maybe change said balance without going through some checks and balances, like making sure that they are the right account holder, that they have enough money in the account to withdraw that kind of money, that they've typed in their PIN number correctly, and so on and so forth. So those are just a couple of things that we're going to want to make sure that we do prior to making modifications to that. And that's all stuff that we can take care of over here in class persons and then access those pieces of information over here in the persons test file. Okay. So as a bit of an intro to objects, those are a couple things that you need to know. So these are what we call object attributes, anything that starts with the word self. Now there are different kinds of attributes as you go through here. So these is our constructor function. Build object attributes. And just so that you can see that this function's actually running and executing and the time at which it does, let's put a quick print statement in here. Or called. And just as we're doing this, I'm going to delete these lines, right? Because they're not really helping us at all in this particular instance. So you're going to notice that when I run this now, it should print constructor called constructor calls. Why? Well, because I use this function here, this person function, and even though there's not a single person function written anywhere, anytime I use the name of a class as a function over here in a test file or any other kind of file, what it will do is execute this init function. And that init function needs to have an argument list that matches the parameter list that we have here. Here we have 1, 2, 3 parameters. Self doesn't count, and I need to send it 1, 2, 3 attributes, or I should say arguments as we go through. Person 2 is sort of the same idea. So you can see the constructor was called. Now there is one other type of attribute that you should be aware of, and those aren't object attributes. They are what we call static attributes. These are attributes that don't pertain to any one particular instance, but would likely pertain to the class as a whole. Maybe something like num people. Maybe in this program I would like to know exactly how many people have been created in any other program that's running. So as this is going, I can kind of track that number. So every time this constructor gets called, let's take num people and up it by 1. So now to gain access to that, attributes generally get access with the word self, but since num people has no relationship to self, what I have to do is call it through the class name. So I'm going to go person dot num people plus equals 1. Okay. So what you'll see here is that when I go through this particular program, I can print out person.numPeople, and it is a public attribute. I don't see any reason to make static attributes private. Okay, they belong to the class. They're meant to get manipulated, and they're only ever going to get manipulated from within the class, most likely. So here, what you'll see, since I created 2 instances, when it prints out, it's going to say the constructor was called twice, and it's going to print the number 2. Well, that's because numPeople now has the number 2 associated with it, because every time we call this function, this is running, and the last line of code within there is to increase numPeople by 1. So static attributes are kind of nice to have around, or at least the ability to access when you have information that belongs in the class because it's information that pertains to the class, but it's not information that pertains to any one particular object. It doesn't make sense for person 1 or person 2 to really know how many people there are. That's not their business, it's not their job. Their job is to understand information about themselves and only themselves, about person 1, about Zach, and person 2, about Sam. Okay? His address and his phone number. The person class as a whole, it's its job to know how to do everything about everyone, and one of those things could be how many people were created. Could we have easily have just done that over here in the main method? Absolutely. Every time that's called, we could up it by 1, but it actually makes more sense for it to be over here, and that way I don't have to bloat this with a lot of code that just doesn't make a whole lot of sense, and I can just type it once and it will do it for me, which is really kind of neat. So basically, in this video, I just wanted to get through the idea of what a class was and how it's going to bring it all together, and only go through the attributes and the constructor of the class. We'll talk about some of the other features of a class as we get into the second and third video. In the second video, we're going to talk about, well, since now we made these private, well, how do we actually change them? Like, we should be able to change a person's name. Let's say they get married and their last name has to change. Well, we can do that. Or they move and we need to change their address, or they get a new phone and we have to update their phone number. There's no reason we shouldn't be able to mutate those in some way. So in the next video, we're going to talk about accessor methods and mutator methods so that we can actually gain access to that private data over here in the test class and change it in some way, but making sure that we do it in an appropriate manner so that there's some checks and balances that go into this, without being able to just lay it in there without it being appropriate information. So that's going to wrap it up for the very first video on just attributes, classes, and constructors. In the second video, like I said, we'll start talking about accessor and mutator methods. In the third video, we'll start talking about more about methods in general, object methods and static methods. And then lastly, we'll kind of put it all together in one big example where we'll actually make something and a full-blown test class that kind of makes sense, and it'll start to see how it all kind of comes together in one big piece so that you can get ready for your next lab. So that'll kind of wrap this video up. Hopefully you get an opportunity to read that chapter and make sure that you check out the next few videos. So we'll see you in the next one.